Welcome all. Now I am going to discuss question number 9 from the GATE 2021 paper Electrical Engineering. The question is, consider a power system consisting of n number of buses. Buses in this power system are categorized into slack bus, PV buses and PQ buses for the load flow study. The number of PQ buses is NL. The balanced NewtonRaphson method is used to carry out load flow study in polar form. H, S, M, R are the submatrices of the Jacobian matrix J as shown below. The dimension of the submatrix M is. These are the given options. To know the formulation of the Jacobian matrix in the NewtonRaphson method, audience can go through the given NPTEL course or the video link. Let us have a quick recap on Jacobian matrix. From the NewtonRaphson method, the load flow studies expressions are governed by these following equations, which is represented in the matrices form. First, let us discuss the type of buses in the power system. Mainly, the power system is categorized into three types of buses. PQ bus or load bus. PQ bus means known values are P and Q. So, unknown values are V and delta. PV buses. PV buses means specified and knowns are P and V. So, the unknown values are Q and delta. Slack bus. Slack bus means 1 at an angle 0. So, the known values are V and delta. So, unknown values are P and Q. So, from the NewtonRaphson method, these are the matrices that are governed by the load flow studies. Here, delta P and delta Q are the known vector and delta and delta V are the unknown vector. H, S, M, R is the Jacobian matrix. And in the question, it is given that number of load buses are NL. And the slack bus, obviously it is 1. So, the total number of PV buses are total number of buses minus load buses plus slack bus. These are the total number of PV buses in the power system. Let us solve the problem. In the question, it is given that PQ buses are NL. NL is the number of PQ buses and one slack bus is there. One slack bus is there. So, the total number of PV buses are total number of buses in the power system minus number of load buses plus one slack bus. This is the total number of the PV buses in the power system. So, we need to calculate the dimension of the M submatrix in the Jacobian matrix. PQ buses means known values are P and Q, right? P and Q. Unknown buses are V and delta. Similarly, for the PV buses, known values are P and V. Unknown values are Q and delta. Unknown values are Q and delta. So, number of known values are NL. Number of unknown values also NL. NL number of P and NL number of Q. Here, N minus NL plus 1 number of P and V's we know. N minus NL plus 1 unknowns of Q and delta we know. So, from the Jacobian matrix, this is delta P, delta Q is equal to H, S, M, R into delta V, delta delta and delta V. Delta P and delta Q, this side this is known vector, and delta delta and delta V is the unknown vector. So number of P we know that NL plus N minus NL minus 1. So delta P NL plus N minus NL plus 1. Let me simplify this one. N minus 1 P delta P's we know. Q values are NL only. Since this is known vector, for PQ bus only we know. So NL number of delta Q's we know. Here unknown values delta delta. How many unknowns we know? We have to find delta delta. Here also NL is unknown. Here also delta is unknown. So NL plus N minus NL plus 1. These are the number of unknown deltas, that is N minus 1. And delta V is NL, because here V is known. So number of delta V is unknown, it is NL. And M is related to delta Q and delta delta. So delta Q is equal to M into delta delta, right? So how many delta Q's we know each? How many delta Q's we know? That is NL. How many delta deltas we unknown each other, means we have to find, that is N minus 1. NL cross N minus 1. So the size of the Jacobian submatrix M is NL cross N minus 1. Option A is the correct answer. Thank you.